Mr. Moore's math class!
Hey! Thank you very much, guys, for taking my advice and tuning into today's special episode, which is all about finding the equation of a straight line. Now, like I said during the previous lesson, this lesson is all about helping you with some of the more complex skills involved in this task. Alright, we're going to be talking about parallel lines and perpendicular lines, and we're also going to need to know how to do simultaneous equations in order to be able to find a point. So let's use all of this information, what you're about to learn here, in order to be able to attempt some of the more difficult questions in this topic. Let's go. Alright guys, so in the first worked example, we're actually going to have a look at a problem involving parallel lines. But before we do that, let's have a look at some of the theory behind parallel lines.
Alright, so let's have a look at the following lines, shall we? That is y equals 2x plus 8, y equals 2x plus 4, y equals 2x, y equals 2x minus 4, and y equals 2x minus 8. Now if you have a look at each one of these equations, all the numbers out the front of the x are positive too. Therefore, all of the lines have the same gradient. And as you can see when you look at the graph, that these lines will actually never touch. And we know that two lines that never touch are said to be parallel. Therefore, if you are told that a line is parallel with another line, then that means that the two lines have the same gradient.
And now it's time for the worked example. Yeah.
So things are starting to get a little bit harder now when finding the equation of the line. The question says find the equation of the line that is parallel to the line 6x plus 4y plus 3 equals 0 and passes through the point 7, negative 3. Now, remember, whenever we need to find the equation of the line, we must have two things. One is a point, and two is the gradient, in order to substitute into the y minus y1 equals m bracket x minus x1 formula. Alright, well let's have a look at the information that we've got. Highlight all the key points. Find the equation of the line that is parallel to the line 6x plus 4y plus 3. So parallel, that basically is hinting at gradient, and passes through the point 7, negative 3. So the point 7, negative 3. Right, so my point here, we know, is 7, negative 3, but it hasn't actually told us the gradient, but we can find out our gradient using the information that's been provided. Now before we go any further, let's just have a quick squeeze at the parallel lines and what their definition is in terms of talking about linear graphs. Now what you can see here is a graph with 4 different linear lines on it. They're actually all parallel, that is, they'll never meet. Now the thing that actually makes them parallel is that they've all got the same gradient or the same steepness, but they've got a different y-intercept. So for lines to be parallel, it means they must have the same gradient. Right, so what does that mean for this? Well, it means that if one of these lines, for example, had the equation 6x plus 4y plus 3 equals 0, and the line that we're looking for has the same gradient as that, but goes to a different point, say at 7, negative 3, it means that this here has the same gradient as this line here. And how do we find the gradient of this line? Well, what we need to do is we need to put it into y equals mx plus c form, and this m value will tell us the value of the gradient. So let's do that. We've got our equation here, 6x plus 4y plus 3 is equal to 0. And let's rearrange now and get into the y equals mx plus c form. So first of all, let's move over the 3. So you get 6x plus 4y is equal to negative 3. 4y, subtract 6x from both sides, is equal to negative 6x minus 3. We still need to get y on its own, so let's divide both sides by 4. Divide by 4, and divide by 4. So these cancel out to find y is equal to negative 6 on 4, x minus 3 on 4. And of course we can cancel the negative 6 on 4 down to y is equal to negative 6 on 4. It becomes negative 3 on 2 because there's a common factor of 2, x minus 3 on 4. Therefore, my gradient of this line is equal to negative 3 on 2. So that's the gradient of this line. I'm looking for the gradient of this line. What's going to be the same. So that means my gradient that I'm working with actually happens to be negative 3 on 2. Now all I need to do is substitute these two pieces of information into this formula. So let's do that over here. I've got y minus y1 equals m bracket x minus x1. Alright, write out my pieces of information. So I've got m is equal to negative 3 on 2, and my point is equal to 7, negative 3, and we'll call this one x1 and this one y1. Let's go through and substitute in now. So you get y minus y1 being negative 3 in brackets is equal to m negative 3 on 2, x minus x1 being 7. expand the brackets, etc. now, so you get y minus negative 3 becomes y plus 3 is equal to negative 3 on 2 x minus 7. Now when we multiply the negative 3 on 2 times x minus 7, what we can actually do is we can do like this. We can say y plus 3 is equal to negative 3 bracket x minus 7 over 2, just because it will help you understand what we're going to do with this 2 in a second. Okay, so I don't like the fractions because I reckon they look ugly, so I'm going to get rid of this 2 by multiplying everything by 2. So we multiply that by 2 as well as everything over this side. So you end up with 2y plus 6 is equal to, the 2's will cancel out, negative 3 x minus 7, and all of a sudden everything looks a lot more hunky-dory. So you get 2y plus 6 is equal to negative 3x plus 21. Okay, so let's rearrange it and put in the ax plus by plus c form. So add 3x, and that ends up getting us 3x plus 2y plus 6 is equal to 21. Minus 21 from both sides ends up getting us 3x plus 2y minus 15 is equal to 0. Putting into the y equals mx plus c form, we have 3x plus 2y minus 15 is equal to 0. Add 15 to both sides, so you get 3x plus 2y is equal to 15. Subtract 3x from both sides, so you get 2y is equal to 15 minus 3x. Divide both sides by 2, gets us y is equal to 15 on 2 minus 3 on 2x. I can rearrange that to make it y is equal to negative 3 on 2x plus 15 on 2. And here we have the two different ways of writing out the equations of the line. This one here in the ax plus by plus c form, and then this one here is y equals mx plus c form. Alright, so it's now time to press pause once again and attempt the following question. Remember, of course, like always, press play to check your solutions against mine once you're done. Okay, so before we get started, what we should always do is go through and highlight all the key points in the question. So find the equation of the line that is parallel to the line y is equal to 2 on 5x minus 9. So if it's parallel to that, and passes through the point 4, negative 7. Both of these are important because we need to have a point and a gradient in order to find the equation of a line. So let's go through and write this in. Our point is the point 4, negative 7, as we've just highlighted up here. And our gradient, well, that's parallel to the line y is equal to 2 on 5x minus 9. Alright, so you can see I've written that just here. Now, if that's the case, then this is already in the form y equals mx plus c form, and we know that the gradient can be found by the letter m here, or the 2 on 5. So we know that the gradient is actually 2 on 5. Okay, so I've written out the formula to find the equation of the line, and I know that my m is equal to 2 on 5, and my point here is x1, y1 being 4, negative 7. So substituting those in now, y minus y1 being negative 7 equals m being 2 over 5, x minus x1 being 4. Go through and simplify now. Negatives here become y plus 7, and I've just left the rest as is without the brackets. I've then got y plus 7 and put it all over 5 because it just makes it a little bit easier to understand when I multiply both sides by 5 down here. So multiplying both sides by 5 times by 5 times by 5, everything on this side and also everything on this side, you get 5y plus 35, and the 5's here cancel out. So then you end up getting 5y plus 35, and when we expand this you get 2x minus 8. So now what I'm going to do is subtract 2x from both sides. 2x's here will cancel out, of course, and that will get me negative 2x plus 5y plus 35 is equal to negative 8. Okay, now adding 8 to both sides plus 8 to both sides ends up getting us negative 2x plus 5y plus 43 is equal to 0. This here is in the ax plus by plus c equals 0 form. Now we want to put it in the y equals mx plus c form. So what we're going to do is we're going to add 2x to both sides. These of course will cancel out, leaving us with 5y plus 43 is equal to 2x. Now what we're going to do is subtract 43 from both sides. These will cancel out, leaving us with 5y is equal to 2x minus 43. And divide both sides by 5, being everything from the other side. 5's cancel out here, leaving us with y is equal to 2 over 5x minus 43 over 5.